Continuing with our examples, here we have f of x equals x squared plus 1 all over x minus 2. So this would be polynomial form. So here, find your y concepts. Here we have a leading term that's raised to the power of 2. This is a 1. Top power bigger than the bottom power. Case 3, no horizontal asymptote. Y-intercept, 1 over negative 2. That's my y-intercept. Now, since there's no horizontal asymptote, we got to do a little algebra to go find it. We need to take x minus 2 and divide it into x squared plus 1. Now, because there's no x term up here, you need to put in a plus 0x to hold its place value. So to do your polynomial long division, you start and you only divide leading terms. X squared divided by x is an x. Line it up above the x term. Next, you then take this x and you multiply it to everything out front and line it up underneath. X times x, x squared, x times minus 2, minus 2x. And then you're going to subtract those two columns. What should happen is the leading terms must always cancel. That's gone. 0 minus a negative plus plus. That's a 2x. Bring down the plus 1. And now you repeat the process because now my new leading term is 2x. And I divide it to the leading term on the outside. So 2x divided by x is a positive 2. You line it up over the constant and you say, I'm done. Because as soon as you get this plus 2 here, anything after that is going to be a remainder. I don't have to multiply it through. So y equals x plus 2 is my slant asymptote. All right, so let's go factor the... Wait a minute. I just looked at the top. X squared plus 1, that's not going to factor. Vertical asymptotes, x minus 2 equals 0. We can solve that for x. That's 2. But if I try to solve this by subtracting over the 1, x squared equals a negative 1, that's not going to happen. So here there are no x-intercepts. Whew, I am short some points here. Let's see. Okay, let's start to graph. Vertical asymptote at 2, open circle. No other x-intercepts. Okay. Right-hand behavior, positive x squared divided by positive x. Right-hand behavior is positive. And then after that vertical asymptote, everything over here is negative. Don't let the y-axis influence you and say, oh, there's positives over here. Nope. So I'm going to draw in my vertical asymptote. And now I'm going to draw in my slant asymptote. So we're going to go to the y-intercept of 2. And then we're going to go up 1, right 1, plot a point, up 1, right 1, plot a point. And there's going to be my slanted asymptote line. My y-intercept at 0, negative 1/2. So wow, basically all I have is 1 point to go off of here. All right, so looking at this point here, well, that's a good point because the y is negative. The y-coordinate is negative and I'm in a negative region. So from this point I have to go down and approach that vertical asymptote. And then over here there's no x-intercept to cross, so basically from this y-intercept I then have to kind of attack that slanted asymptote and stay underneath it. But I still have a positive region. Okay, so down on the left side of the vertical asymptote, up on the right. So I'm up here, and I'm going to come down, turn, and then run next to that slant asymptote. So my graph is going to look something like that. All right, example D. All right, polynomial form. Find your horizontal asymptote. We have x squared over x squared. Case number 2, leading coefficient ratio 2 over 1 becomes a 2. Y-intercept, look at those constants. We have negative 9 over negative 9. That will simplify to a 1, so 0, 1's my y-intercept. All right, now we got to factor the top and the bottom. So we got to factor the x squared minus 9, setting it equal to 0. 2x squared minus 3x minus 9, we'll set that equal to 0. We're going to find our vertical asymptotes and find our x-intercepts. So here you have a difference of perfect squares. That factors to x plus 3 and x minus 3, and the order doesn't matter. Setting these equal to 0, we get x equals 3 and x equals a negative 3. All right, then I come over here and I factor. Let's see, I'm going to have a 2x and an x, and I think we'll break down the 9 to a 3 and a 3. So 2x plus 3 and x minus 3. So that's going to be negative 6x plus 3x is my minus. Oh, wait a minute. Hold the phone. I have 2x minus 3's. I can solve for x-intercepts, but wait a minute. We got to stop here for a second. We got to think about this. If I rewrite this, put these two factors on the bottom, these two factors on the top, these x minus 3's are technically going to simplify away from each other. All right, so this is going to simplify to a 1, and therefore this is my new fraction. Now, I hope you can see this. How can I have a vertical asymptote at 3 and have an x-intercept at 3 at the same time? If I had a vertical asymptote right here, I can't touch it, then you can't have an x-intercept. So these two reduce to a 1 and they simplify away. So no 3, no x-intercept of a 3. These are all gone. However, we're still going to use that 3. I don't want to say I completely cancel it away. I still need it. Because when you get a binomial that's the same on the top and the bottom, you have a hole in your graph. So to find that hole at x equals 3, you plug this 3 into this new simplified reduced rational function. So 2 times 3 will be 6, plus 3 is 9. 3 plus 3, and you substitute in for that x, we'll get a 6. We reduce that to 3 halves. Our hole is at 3 comma 3 halves. So now we got more stuff to plot. All right, so let's, again, take care of all your x's. My vertical asymptote, open circle at negative 3, closed circle at negative 3 halves. Okay, let's see. So right side positive, negative, positive, because again, we're leading terms are positives. So I didn't put the signs in here, so everything's starting to work out okay. If you still need them, you can put them in. Put in my horizontal asymptote at y equals 2, my y-intercept at 0, 1. So like I said, this is all positive to the right of that x-intercept. There's my positive y. So to start to make my graph, oh, wait a minute, before I can make my graph, we got to plot this hole. 3 and 3 halves. All right, so I make my graph. These 2 points, what has to happen from this hole to that y-intercept to this x-intercept, run down next to that vertical asymptote, and then on the other side of the hole, we run next to the horizontal asymptote. So if we're down on the right, we have to be up on the left. So we went from positive y's, there's my negative y's, there's my positive y's. All right, next example. Now you're given a graph or you're given details about a graph and you have to write the function. So the first, well, wait a minute, I notice a hole. So if there's a hole, you're going to have 2 binomial factors that need to be the same, top and bottom. So we'll remember that when we get there. What I like to do is draw in your horizontal asymptote y equals 1, because that's going to tell you something very important. Top power and bottom power have to be the same. I got a vertical asymptote here at x equals 4. And that's going to be my bottom factor. That's my denominator. And there's an x-intercept right here at 5. So creating my two factors, x minus 5 on the top, vertical asymptote factor, x minus 4 on the bottom. Now, the next thing we got to take care of that hole, which is right here at x equals negative 4. So what I need to do is I need to create the binomial x plus 4 and multiply it to the top and the bottom. And this is my rational function right there. Now, they usually ask you just to leave this in factored form. That's fine. We don't need to multiply it out. Now, the second thing you got to remember about this horizontal asymptote, if it's not at 0, now let's say if this was a 2 or a 3, you got to put that number on top because you need that 2 over 1 or 3 over 1. So being a 1, you really don't need it. But if it's anything other than a 0, I would get good practice of taking that 1 from the horizontal asymptote and putting it out in front just to create a good habit. Part B. All right, let's see what we got here. Oh, they're already giving me all my information. Okay. Vertical asymptote, binomial, x minus 1, that's on the bottom. X-intercept at 3, x minus 3 on the top. Let's see, horizontal asymptote at y equals negative 1. Okay, that means negative in front. Like I said, put that 1 to the top. If it's negative 1, put it on the top. Let's see, y-intercept is a negative 3. Let's see if that's what we get. If I were to distribute this negative 1, I get negative x plus 3. 3 over negative 1, yep, that's a negative 3, so my y-intercept checks out. And you can have either one of these two as your final answer.